Assalamualaikum and salam sejahtera. My name is Syazwani binti Ismail. My magic number BI24110214. This is video presentation for individual assignment KT 14203 Computer Architecture and Organization. Okay, let's start with the question 1, where we are given a 10-bit data word with 4 check bits and store across 14 positions. First, we will thought that the original check bits is 0011, which store in check bits C1 1, C2 1, C4 0, C8 0. Okay, next we will check the word that was fetched, which is received. Calculate the new check bits from the fetch by using parity checks. Okay, so what is parity checks? Parity checks is a simple method that used to detect error in digital data. There are two types, which is even parity and odd parity. Okay, after applying the parity in position number, I have summed the parity check. We got the new check bit 1001. Okay, next, require the syndrome. Okay, to find where the error occur, we will XOR the original check bits with the new check bits. So we got the result of 1010 in binary, which means that the error is in bit position 10. Okay, how we correct the error? So we go to the position 10 and we see the bit where 1, we flip it to 0. And that's how we got the original data word 1000101001. Next, we will discuss about question 2, where we need to compute the product of x negative 12 and y negative 4, and y is equal to 4 using both algorithm in 5-bit words. Okay, first we need to represent plus 12 in binary using 5-bit, which is 0, 1, 1, 0, 0. And then we need to invert it to have the 5-bit 2's complements of negative 12. So the 1, 0, 1, 0, 1, 1, 0, 0, we will invert it to 1, 0, 0, 1, 1. And then we will add 1. I will make the value of 1, 0, 1, 0, 0. That is the 5-bit 2's complements of negative 12. Okay, we also have y equal to 4. Change it to binary. We got value of 0, 0, 1, 0, 0. Okay, next we will, based on the 5-bit word, we will undergo 5 cycle. First cycle, we will have q equal to 0 and q minus 1 equal to 0. So we will do nothing and it will perform arithmetic shift to the right for a, q and q minus 1. So a will get 0, 0, 0, 0, 0, 0, 0, q becomes 0, 0, 0, 1, 0, and q minus 1 becomes 0. And then for the next cycle, cycle 2, q also 0, q minus 1 is also 0. So same, it will do nothing. And then it will perform another shift to the right. So the remains will be 0, 0, 0, 0, 2. Q become 0, 0, 0, 0, 1, shift to the right. And q minus 1 still 0. And then to the cycle 3, we also have we change the value of q is changed to 1 and value of q minus 1 still 0. So it will perform a minus m. So we got the value of a 0, 0, 0, 0 minus 1, 0, 1, 0, 0, and the value is 0, 1, 1, 0, 0. Okay, then it will perform a right shift. So we take the value of a minus m to a, so it become 0, 1, 1, 0, 0. Q become 0, 0, 0, 0. Q minus 1 become 1. Okay, next cycle is cycle 4. And then again we have q equal to 0, q minus 1 equal to 1. So it will perform a plus m, where the value of a is 0, 1, 1, 0, 0 plus 1, 0, 1, 0, 0 equal to value 1, 1, 0, 0, 0. Next, it will perform a shift to the right, and the value, we got the value a plus m. We take it to a 1, 1, 1, 0, 0. Q remains as 0, 0, 0, 0, and q minus 1 become 0. Next is cycle 5. Okay, the last is q have 0 and q minus 1 have 0, so we got to do nothing. And then we perform the final right shift, where a become 1, 1, 1, 1, 0, and q remains as 0, 0, 0, 0, 0. So that's how we got the value of a 1, 1, 1, 1, 0, q 0, 0, 0, 0. We combine it and will become the value of negative 48. Now let's move to the question 3, where we are I'm going to explain how to perform restoring division by using binary number. So we have dividend, which is 7, and divisor, which is 4. Okay, so dividend 4 is stored in a q register, and write this as a q equal to 0, 0, 0, 0, 0, 1, 1, 1. And divisor 4 is in binary, write as m equal to 0, 1, 0, 0. Okay, we also set an extra bit r1 equal to 0. And then we will begin the division, which is 4 cycles, since we are using 4 bits. For this first cycle, it will undergo left shift a and q, where a becomes 0, 0, 0, 0, and q become 1, 1, 1, x. It will subtract m from a, where a value is 1, 1, 1, 1, 1, 0, 0, and since the result is negative, a is restored back to 0, 0, 0, 0. Okay, for the second cycle, it will undergo 2 left shift a and q. The value of a is 0, 0, 0, 1, and q is 1, 0, 0, x. Okay, it will subtract m, which will give us the value of a is 1, 1, 0, 1, which is negative. So it is restored back a to 0, 0, 0, 1. And then we will undergo cycle 3, also left shift a and q. The value of a is 0, 0, 1, 1. Q is 0, 0, 0, x. And it will subtract m, where we got the value of a is 1, 1, 1, 1, which is negative. So it will restore a back to 0, 0, 1, 1. And then for final cycle, which is cycle 4, it will undergo left shift a and q also, where a is 0, 1, 1, 0, and q is 0, 0, 0, x. It will subtract m, where a value is 0, 0, 1, 0, which is positive. So it will keep a as is. And then during this, set q will be equal to 1. That's how we got the value of quotient 0, 0, 1, 0, which is the value of 2, and remainder is 0, 0, 0, 1, which is the value of 1. So q is 2, a is 1. Now we move to the last question, which is question 4. For question 4a, there are the memory. For address 10 is 50, address 20 is 50 also, address 30 is 40, address 40 is 60, address 50 is 80. For question 4a, load immediate 40. That means we load the number 40 directly into the accumulator. So the value would be 40. And for B, load direct 20. This means we need to go to the memory address of 20, and it holds the value of 50. That's how we got 50 as the accumulator. For the 4C, load indirect 30. First, we need to go to address 30, and then address 30 pointed to 40. It holds the value of 40. And then we need to go back to the address of 40, where it stored the value of 60. So the accumulator would become 60. And for D, load indirect 10. First, we need to go to the address 10, and then where it holds the value of 50. So we need to go back to the address of 50 where it holds the value of 80. That's how 80 become the accumulator.